Hello to all the friends if she can fix it. Today, a 30-year-old secret is about to awaken. The young woman enters the forest with a metal detector, not knowing the signal below will change the course of her day. Among banana trees and weeds rising above her knees, she patiently sweeps the ground in parallel passes. Moving slowly and evenly keeps the coil from missing anything, while helping separate real metal from mineralized stone. The signal rises and falls beneath the dense vegetation, forcing her to return and scan the same spot several times. A small object usually produces a short, broken tone, but this signal stretches across an unusually wide area. She lowers the search coil close to the soil and changes direction, trying to define the exact boundary of the metal mass below. The result shows that this is not shallow buried scrap, but something trapped beneath earth compacted for many years. Stories of the landslide that struck 30 years ago return to mind, as the signal continues beneath the thick cover of grass. She marks the location and studies the surrounding slope, because digging the wrong way could trigger another collapse. Her backpack is placed beside a banana tree for the tools, and the search has now turned into a full excavation. chooses a small shovel and thick gloves instead of rushing, because whatever lies below may be fragile and badly decayed. The first layer is soft, but the ground hardens with depth, showing how mud and rock have compressed it for years. She widens the pit in steps so she can stand securely, and avoids creating a vertical wall that could suddenly cave in. A patch of blue paint suddenly appears beneath the shovel, and she immediately switches to a smaller tool around it. The curve of the metal looks nothing like a box or machine, but resembles part of a car body crushed under the ground. The deeper she digs, the farther the metal outline continues, confirming that the object is far larger than she expected. She never strikes the surface directly because the steel is weak, and every shovel stroke must now run parallel to the panel. The pit is already deeper than her waist, yet the object continues, and she realizes an entire car may be buried underneath. Excavated soil is moved away to reduce pressure on the walls, an essential safety rule when digging into sloping ground. The roof slowly emerges beneath patches of spreading rust, like evidence that time has sealed away for 3 decades. She checks the window edges and roof pillars before continuing, because the frame could collapse if its support disappears at once. After hours of digging, a large part of the body is exposed, but soil still fills the cabin and completely covers the front. Pulling now could bend the floor and tear the pillars apart, because wet earth suction can exceed the car's own weight many times. She calls in an excavator to remove the outer bank of soil, but keeps its bucket a safe distance from the fragile body.
Alo anh ạ. Anh ơi,
The
thu xếp
final
xô em cái xe
section
với.
must still be cleared by hand to preserve
Vâng vâng,
the
để em gửi địa chỉ cho
frame
anh nhá.
and to keep the bucket from cutting remaining wires or lines. The excavator peels away heavy layers behind the car, while she watches the vibration and movement of the pit walls. If the body shifts even a few uncontrolled centimeters, the rotten pillars could fold and permanently deform the cabin. Once the larger mass of earth has been removed, she returns with a small shovel close to the thin body panels. She cuts a drainage channel around the bottom of the pit, preventing mud from flowing back beneath the vehicle. The curve of the roof and trunk lid can now be recognized, yet the car still lies deep as though the oath refuses to release it. She excavates both sides evenly to release the load and balance, preventing the body from twisting before it can be lifted. The front appears with almost none of its original paint intact, while plastic and rubber parts have turned brittle after 30 wet years. She uses a hand trowel around the light and grille, because those details may later identify the car's original model. Thick mud is removed from the cabin one small shovel at a time, cutting hundreds of kilograms from the load before extraction. She avoids stepping hard on the floor because corrosion has weakened it, and one mistake could send her foot straight through the underbody. The doors and roof finally break free of the earth, revealing a sedan whose basic shape is remarkably complete. That completeness exists only on the outside, because water and mud may have destroyed the engine internally. The 30-year-old car now rests fully exposed in the pit, but the hardest part of the rescue is only beginning. Before lifting, she checks for structural load points on the body, so no cable is attached to metal that is rotten or hollow. She connects a gauge to a tire valve to test air retention, because inflated tires will reduce drag during extraction. The needle barely moves after so many years underground, meaning the tire, valve, and rim bead all require inspection. Compressed air is added gradually instead of all at once, so she can watch for bulging sidewalls, cracks, or sudden failure. At the first sound of a leak, she stops and moves to the next wheel, because a tire explosion inside the narrow pit could be severe. Airlines are positioned around the car to lift one corner at a time, while creating space for loose soil to escape from underneath. She does not attempt to raise the entire car in one motion, but increases the height in stages to prevent frame twist. Pneumatic lifting bags are slid beneath the strongest available points, separating the underbody from the mud's powerful suction. Each time a bag expands, she adds heavy wooden cribbing, so the car cannot fall if the air system suddenly loses pressure.
Dừng lại thôi.
The final wheel breaks free from the compacted ground, and the new clearance lets her inspect the suspension beneath. Many joints are seized with rust, but the frame remains connected, strong enough for the car to be pulled out very slowly. After hours of careful leveling, the car reaches solid ground, leaving behind the pit that held it captive for 30 years. She keeps the pulling speed low and watches all four wheels, because a seized hub could shift the cable or tear the floor. At the workshop, the hood is opened for the first time in decades, and the smell of wet soil and old oil escapes the engine bay. She does not try to turn the engine or apply power yet, because every fluid and electrical circuit must be checked first. Mud covers almost the entire engine and front structure, hiding bolts, hoses, and electrical connections from view. She begins by photographing every component in its original position, creating a reference map before hundreds of parts are removed. The lower body shows deep corrosion in many areas, but the main structural rails have not completely failed. She taps each steel panel with a rubber mallet, using the sound to separate solid metal from corrosion-thinned areas. The doors are open to examine the pillars and hinges, which reveal whether the body is still straight enough to restore. The gaps are uneven but remain within a correctable range, giving her another reason to continue this seemingly impossible build. Seats and mud-soaked carpeting are removed first, reducing weight and opening access to the wiring harness. She labels every connector before separating it, preventing confusion when the dashboard is installed again. Beneath the carpet lie dozens of kilograms of hardened mud, covering drainage channels and the floor's original weld seams. She studies the rust color around every panel joint, because trapped water often corrodes these areas from inside out. Mud is lifted from the cabin by hand in careful layers, so hidden electrical wires are not torn in the process. This rough cleaning reveals the real condition of the floor and shows which sections need replacement rather than sanding. A pressure washer is prepared with the correct nozzle, but pressure will be reduced near seals and electrical plugs. High-pressure water can remove mud extremely quickly, but the wrong angle can drive contamination deep into bearings. Insulation panels and moisture-absorbing material are removed because they retain water longest and accelerate floor corrosion. She dismantles from top to bottom in a controlled order, so every intact component can later serve as a restoration template. The trunk is scraped clean before water is introduced, preventing mud from blocking drains and ventilation passages. spare wheel well in every folded metal seam, where landslide damage or impact cracks can remain hidden. Compacted dirt under the car is loosened with hand tools, revealing fuel lines and suspension mounting points. She avoids force around the rusted brake lines because they may crumble and become useless as fabrication patterns. Every floor channel and reinforcement rail is scraped by hand until the original factory weld lines begin to appear. Those traces reveal the car's original construction before any steel beyond repair is cut away. The first stream of water carries away black mud and old oil, while she always directs the spray outward from electrical plugs. This washing method limits water entry into the connectors and exposes wire sections whose insulation has already failed. The old body color slowly reappears beneath the flowing water, showing that some areas looked worse only because of the mud. Even so, she lets the car dry fully before judging the damage, because wet steel can make deep pitting look deceptively mild. The empty cabin is washed from the roof down to the floor, so contamination follows one direction and cannot settle again. She keeps the nozzle away from thin folded edges, preventing water pressure from denting already weakened steel. The seats are washed separately to remove soil and mold, but the foam must be assessed before any reuse is considered. Solid seat frames can be restored with corrosion treatment, while rotten padding must be replaced for hygiene and safety. Cleaning foam covers the body to break down decades of oil, preparing the bare surfaces for a more accurate inspection. She lets the chemical work before rinsing it away, avoiding aggressive scrubbing that could damage surviving paint. After deep cleaning, the sedan's true shape becomes visible, with extensive rust but an overall structure worth saving. She measures diagonally across the doors and engine bay, checking that the body has not twisted beyond repair limits. Every door is cleaned along its inner edge and drain holes, where trapped mud usually causes corrosion from the inside. She labels each door according to its original position, because hinge and latch where it differs from one opening to another. Clean parts are separated and left to dry naturally, reducing trapped moisture inside frames and layered materials. Organizing components into groups from the beginning will save many hours when the car reaches reassembly. The dashboard is lifted out after every connector is labeled, exposing the wiring harness and firewall behind the engine bay. She applies even force at several points rather than one corner, preventing the age-brittled plastic from cracking. The center control assembly is dismantled layer by layer, including switches, power wiring, and mechanical control linkages. She checks connector pins for green copper and black burning, signs of oxidation or a short circuit before the burial. The dashboard head is separated from its inner metal frame, allowing each material to be cleaned and repaired differently. Every screw is stored on a location diagram, so the wrong length cannot pierce the plastic during assembly. In the engine bay, she removes external hoses and accessories, gaining access without snapping brittle fittings. Old oil, coolant, and fuel are drained into separate containers because most contaminated fluids require special handling. The car is secured on 4 load-rated jack stands before any heavy component is removed from underneath. She rocks the body to verify that it is stable, because a hydraulic jack lifts weight but must never hold it long term. The C's exhaust flange is soaked with penetrating oil, then loosened gradually to avoid snapping bolts in the engine block. When the joint refuses to move, she cleans the exposed threads, reducing the risk of drilling out a broken bolt later. The chain hoist is aligned with the engine assembly center of gravity, and the chains attach only to factory-designed lifting eyes. Before lifting, she checks every wire, hose, and engine mount, because one remaining connection could tear out of the body. The engine rises 1 centimeter at a time as she watches closely, keeping the transmission clear of the firewall and front structure. She continuously adjusts the assembly's lifting angle, allowing the heavy unit to clear the bay without bending the frame. The cabin wiring harness is carefully removed from the body, and each branch is bundled according to its operating area. She tests wire resistance instead of trusting appearance alone, because copper can corrode while its outer insulation looks intact. With the engine and interior removed from the shell, she can finally assess the full extent of the corrosion. Sound metal will remain to preserve the factory dimensions, and only sections that have lost strength will be cut and replaced. Engine mounts and underbody attachment points are inspected closely, because they must carry full torque when the engine runs again. She measures the offset between mounting holes, looking for distortion caused by the pressure of the landslide. The engine is placed on a stand for complete disassembly, because turning a mud-flooded engine could destroy every bearing surface. She keeps all components in order by cylinder, so their existing wear patterns can provide useful evidence. The intake, exhaust, and external accessories come off first, reducing the weight before the cylinder head is opened. Every exposed opening is covered immediately after removal, keeping sand and rust particles out of the internal oil passages. The cylinder head is lifted after its bolts are loosened in sequence, preventing distortion of a surface exposed to moisture and heat for years. Below it, the combustion chambers are coated with deposits and rust, but the first inspection reveals no major visible cracks. The old oil drains out as a thick black mixture with water, proving that the engine was breached a very long time ago. She will not reuse a single seal or gasket, because 30-year-old rubber can no longer seal reliably. The cam gears and timing drive are marked before removal, preserving information about the original valve timing position. Those alignment marks will be verified again during assembly, because even one peak of error can rob the engine of power. Deeply rusted bolts are removed with controlled torque, using heat and penetrant instead of brute force. She stops whenever the threads begin to feel twisted, because saving an original threaded hole matters more than speed. The cylinder bores show surface rust but no broken walls, and she measures several heights to check taper. If the measurements remain within limits, the block can be honed or bored, rather than discarding the car's original heart. The flywheel and clutch assembly are removed from the crankshaft, exposing the friction surface and rear support bearing for inspection. She marks the installed orientation before dismantling, because rotational balance directly affects engine vibration. Opening the oil pan exposes the crankshaft and connecting rod ends, critical parts that survive on an oil film only microns thick. journals for scoring, discoloration, and pitting, clues that reveal oil starvation or water contamination. Rod cap bolts are loosened in the proper order, and every bearing shell is kept separately for wear comparison. No rotating component will be reinstalled after cleaning alone, because every operating clearance must be measured precisely. The step transmission case is separated with a rubber mallet. Never a steel chisel that could create a new oil leak at the joint. As the case tabs begin to open, she checks the locating dowels, because missing dowels can misalign the gearbox shafts on assembly. Old bearings are extracted with the correct size tool, so force passes through the loaded race rather than the rolling elements. She turns every bearing by hand and listens for grinding, and any bearing exposed to water will be replaced even if it still moves. The differential gear is an intact but dirty ring gear, and she checks every tooth for pitting with tips. Gear backlash will be reset with precision shims, because a small error creates heat and whining at road speed. Degreasers and cleaners are selected for each material, protecting aluminum, rubber, and any usable coating. She wears gloves and separates the chemical waste, because a proper restoration must protect both people and the environment. Every groove and oil passage in the gearbox case is scrubbed clean, until no residue remains that could return to the bearings. surfaces are cleaned with non-scratching tools, allowing the new sealant to compress evenly when the bolts are tightened. Over-polished enough to erase its original contact pattern. After drying, compressed air is blown through every oil passage, confirming that no water or debris remains trapped inside. The camshaft, crankshaft, and working surfaces are checked again, then coated with assembly lubricant to prevent a dry start. She measures runout on supports instead of judging by sight, because even a slightly bent shaft can destroy bearings quickly. Steel housings are derusted and given a new protective coating, while all mating surfaces and threaded holes stay carefully masked. Paint is only meant to stop external corrosion and must never enter an oil passage or contact surface. The starter motor is tested on an independent power source, checking the solenoid, rotation direction, and current draw. A motor that spins but draws excessive current is still faulty, because it can overheat wiring and collapse battery voltage during cranking. The transmission shafts and gears return in their correct order, while the synchronizer rings are checked for proper grip. She selects every gear by hand before closing the case, so any binding is found while the mechanism remains visible. Gear engagement is checked through a complete rotation, with no tight spots or abnormal scraping anywhere in the sidewall. Assembly oil is applied to the bearing's clear teeth, preventing dry contact during the first seconds of operation. Transmission case is seated in the flocating valves, then tightened diagonally to the specified torque. Sealant is applied only as a thin, continuous bead, because excess material can break off and block an oil passage. The oil pump and supply passages are installed before the sump, because this system decides whether the engine survives its first start. She turns the pump by hand to confirm it is free, while also measuring the clearance between its gears. The crankshaft is placed on new bearings with assembly lubricant, and the main caps are tightened from the center outward. After every torque stage, she turns the crankshaft by hand, catching a misplaced bearing before damage can occur. The restored oil pan is installed with a new gasket, after both mating surfaces are cleaned completely. The small bolts need only even, moderate torque, because over-tightening can distort the flange and cause an oil leak. The camshaft and valve operating mechanism are reinstalled, with every piston surface lubricated beforehand. She checks the clearance and travel of every valve, because one sticking part can destroy compression in a cylinder. The timing marks between crankshaft and camshaft are aligned precisely, a step that can never be estimated by eye. After setting the timing, she turns the engine through 2 full cycles, confirming that no piston can contact a valve. The cylinder head is tightened in a spiral pattern with a torque wrench, compressing the gasket evenly without warping the head. Every torque value is verified twice, because one loose bolt can let coolant enter a combustion chamber. The intake and exhaust manifolds receive new gaskets, while their flanges are checked with flatness before tightening. She replaces every hardened or cracked vacuum hose, because even a tiny leak can make the engine idle erratically. The pulleys and belt system are aligned on one plane, keeping the belt in its grooves when engine speed rises. She sets belt tension within the correct limit, because too tight damages bearings and too loose causes slippage. The flywheel is tightened to the crankshaft in a cross pattern, with clean threads and the correct thread locking compound. She checks the flywheel face for runout, preventing clutch vibration when the car begins moving. The intake assembly and sensors return around the engine, but every electrical terminal is tested before connection. This inspection resulted in faults, avoiding another engine removal for one failed sensor. The completed engine now waits beside the body, looking nothing like the mud-covered mass first raised from the ground. Yet clean appearance proves absolutely nothing. Only oil pressure and the sound of the running engine can answer. The old fuel tank is removed to drain water and sediment, because even a new filter can prevent this contamination. Allowing no sparks near the remaining fuel vapor. The tank is flushed repeatedly until the diesel becomes clean, then dried completely before returns and filtering is installed. All rubber fuel hoses are replaced at the same time because a small crack could leak and ignite once the car is running. The engine bay receives one final cleaning before the powertrain returns, so no remaining mud enters any newly restored connection. She seals open brake lines and electrical terminals, then dries the entire area with compressed air. Rust on the brake disc shows the system has been used for years, and surface sanding alone cannot make it safe. She measures disc thickness and run out, deciding whether each one can be machined or must be replaced. The brake and hub assemblies are removed from the suspension, exposing caliper pistons, bearings, and dust seals for inspection. Nothing related to braking can be judged by guesswork, and every component must meet specification before road use. Braces and mounting brackets are derusted and protected, while tapered seats and bolt threads remain perfectly clean. She replaces every hardened rubber bushing because they control ride quality and wheel alignment. The wiring harness is laid out according to the diagram, and hidden brakes are replaced with wire of the correct gauge. Connections are soldered and sealed with heat shrink tubing, not temporarily twisted together where resistance and heat can rise. Every connector is continuity tested and labeled by function, returning the electrical system to its original structure. Special attention to body and engine ground cables, because a poor ground can create many seemingly unrelated faults. The engine assembly is lowered into the bay at a calculated angle, aligning the mounts, transmission, and drive shafts together. She tightens nothing fully until every bolt has started by hand, preventing one fixed point from pulling the powertrain out of line. Engine bay connectors are cleaned before reconnection, and every locking tab must click firmly into place. A thin protective coating is applied in moisture-prone areas, but never allowed onto the electrical contact surfaces. The instrument cluster is reconnected to test basic signals, including power, warning lamps, and sensor circuits. Before energizing the complete system, she uses a small protection fuse, limiting damage if one wiring branch still has a short. Every dashboard switch is tested function by function, and all high current loads are checked through their relays. This keeps heavy coolant away from small switch contacts, reducing the risk of melted controls during long-term use. The main power cable is cleaned at both terminals because even thin oxidation can cause voltage drop while cranking. She measures voltage at the battery posts and starter motor, locating whether the loss is in the battery, cable, or ground. The brake fluid reservoir and lines are inspected for leaks before the system receives fresh hydraulic fluid. She never mixes incompatible brake fluid specifications because the wrong type can swell seals and cause brake failure. Every contact in the fuse box is cleaned, and incorrectly rated fuses are replaced with the proper values. A larger fuse does not make a system stronger. It only lets the wire burn before the circuit is protected. Drive shafts and hub assemblies receive new seals and grease, while the center nuts are tightened to specification. She checks the operating angle of each CV joint, preventing vibration and knocking while the wheels are turned. The suspension is rebuilt on new rubber components, and every load-bearing bolt receives a final inspection. Rubber bush joints are fully tightened only at ride height, because tightening them while hanging will twist and destroy them early. Fresh engine oil is added after every drain plug is verified, but she still does not start the engine immediately. The oil pump must first be primed to create pressure, preventing dry bearings and cam surfaces during the first second. Coolant is added slowly and the system is bled correctly, because trapped air can overheat an engine even with a full reservoir. She checks the thermostat and cooling fan operation, two essential safeguards once the engine begins producing heat. The battery is connected last, after every circuit is ready, and she remains beside the master cutoff in case anything goes wrong. The first application of power happens in complete silence, because even a faint burning smell could reveal a serious fault. Dashboard warning lights illuminate after 30 years, showing that the power supply and many control circuits live again. She watches the oil pressure lamp before cranking, because it must switch off quickly once lubrication pressure rises. With the mechanical system showing hope, she turns to the body, where peeling paint hides a network of rust holes. The grinder removes damaged material only down to solid steel, without thinning areas that can still be preserved. A hydraulic jack pushes the crushed roof back into shape, with force spread through wood to avoid creating new distortion. She measures the height on both sides after every lift, restoring symmetry by measurement rather than appearance alone. The oak headliner is removed to expose the roof inner surface, revealing its reinforcement valves and factory welds. before the outer skin is pulled and reshaped further. All failed roofs need to strip back the skin away, so new material is never applied over a clean roof. She keeps the grinder constantly moving, preventing concentrated heat from warping the thin roof panels. Exhaust pockets are opened outward until healthy fuel is reached, because hiding the two-liter filler only guarantees suffocation. She marks areas for welding separately from surface treatment, preserving as much original metal as possible. The doors, hood, and removable panels are separated from the shell, opening access to folded edges and corrosion on the inner faces. Each panel is supported in its natural shape, so it cannot sag while resting on a small pressure point. Large panels are ground in clearly defined sections, with flatness checked by a long straight edge after every pass. She does not chase a polished finish at the beginning, first removing corrosion while preserving the correct body lines. The exposed metal reveals many shallow dents, created by earth pressure and decades underground. Low areas are marked with a dyed coat, so straightening and sanding rely on evidence instead of feel. Old seams are stripped of sealant and rust, revealing how deeply moisture traveled between the steel layers. Only after ever seen has dried completely, can loosen the sealer prevents water from entering again. The grinder removes the last remaining corrosion pockets, while she continuously monitors the thickness of the steel. When light passes through a weakened area, it must be cut out and replaced rather than saved. Body panels are arranged in their exact positions around the car, allowing door gaps and character lines to be aligned together. A beautiful car depends on more than paint. It also requires even gaps and doors that move precisely. A stud welder creates small pulling points on dented metal, letting her restore the surface without drilling holes through it. Each stud receives only the necessary amount of heat, because excess heat can stretch the steel in a new direction. Instead of one violent pull that could stretch or tear the panel. She constantly checks with a straight edge and reflected light until the surface approaches its original curve. The rotten wheel arch is cut away completely, exposing clean steel strong enough to hold a new weld. The patch is shaped to the correct curve and thickness, preventing a rigid stress point that could crack nearby metal. The new steel patch is welded with spaced tack lines, spreading heat and limiting the torsion of the body panel. The weld is ground flush without thinning the surrounding steel, preserving the full strength of the repair patch. She then shines a light from the rear of the panel, searching for pinholes that could allow water through later. The windshield is removed to treat rust around its frame, an area easily missed when painting with the glass fill installed. She cuts the old adhesive evenly around the perimeter, avoiding broken glass or a distortion of the thin frame edge. Every area not intended for paint is carefully masked, with blend lines placed where the new coating can transition cleanly. Good masking keeps sanding dust out of clean compartments and protects threads and precision mounting surfaces. A thin layer of body filler is spread over the straightened roof, only to level the small imperfections that remain. Filler can never replace missing metal, because an excessive layer will crack as the body flexes and heats. The repaired rear quarter receives corrosion-resistant primer, isolating bare steel from moisture before the next stages. She holds the spray gun at a steady distance, creating an even primer coat without heavy runs. The entire body gradually takes on one uniform primer color, making every wave and low spot easier to identify. Angled light becomes a measuring tool, because an uneven surface breaks the reflected line. Small defects are corrected with an extremely thin skim, then leveled again using a long sanding block. She always sends in a crosshatch pattern instead of one direction, preventing grooves and maintaining a smooth curve. The roof is sanded through progressively finer grits, removing deep scratches before moving to fine paper. Each time the grid changes, all previous dust is removed, so a trapped coarse particle cannot scratch the new finish. The trunk and inner edges receive one final inspection, because beautiful exterior paint cannot protect hidden rust inside. She seals every joint and water-trapping cavity, preventing the old corrosion cycle from starting again. The rear body is leveled around the welded repair until her hand can no longer feel the seam transition. A guide coat reveals any remaining low points, a more accurate method than judging the surface color alone. The hood is refinished on a separate stand to preserve its shape, and the underside is cleaned before receiving paint. Drain holes and folded edges remain open, so moisture cannot become trapped beneath the The doors are sanded along their original character lines, keeping the design crisp instead of rounding it under excess material. sander creates a uniform scratch pattern, but edges and body lines still require careful hand finishing. She reduces pressure along panel edges where primer is thinner, avoiding a sand-through that would restart the process. After hours of sanding, body preparation is finally complete, with straight and uniform surfaces under the inspection light. From this point, even one speck of dust can mark the paint, so the work area must be cleaned thoroughly. The final finishing skim is now only film thin, erasing defects that were invisible while the surface remained rough. Once it dries, she checks with both her hands and reflected light, confirming that no raised transition remains. Removable panels receive final sanding before paint day and are spaced apart to prevent contact while being moved. She blows dust from every folded seam because hidden particles can escape when the spray gun starts. Paint is mixed with hardener in the exact specified ratio, and its viscosity is checked before filling the gun. A mixture that is too thick produces orange peel, while one too thin runs easily and covers unevenly. Inner cavities and panel seams are sprayed first, because they become difficult to reach once the body is assembled. She narrows the spray pattern for enclosed areas, achieving coverage without building excessive paint at the edges. housings and the trunk receive a fresh protective coating, defending them from stones, road water, and moisture. Suspension mounting surfaces remain carefully masked, so coating cannot alter their fit or bolt clamping force. White paint begins covering the roof and large panels, transforming the rusted shell into a completely different car. She overlaps every spray pass by a consistent amount, preventing light and dark bands from appearing in daylight. The gun stays perpendicular and moves at a steady speed, while its distance remains unchanged along every pass. She begins moving before pulling the trigger, and releases it before stopping to prevent heavy paint at each end. Doors and removable panels are painted in the same batch, keeping the white shade consistent when they return to the body. Each coat receives enough time for solvent to escape, preventing a dry surface over paint that remains soft underneath. The bright white body now stands inside the workshop. Hard to believe it spent 30 years buried in mud. She still refuses to call the project finished, because beautiful paint matters only when every system is safe. The freshly painted cabin is ready for its interior, with every mounting hole and wiring route preserved. She rechecks the firewall grommets so no wire can rub against sharp steel as the car vibrates. The dashboard is carefully returned to the cabin, and every connector follows the label assigned at disassembly. She tests each switch before installing the final trim, so one forgotten connector cannot force the dashboard out again. The new liner is spread evenly from the ground, preventing wrinkles and preserving all grab handle mounting points. She keeps the material away from adhesive that is still wet, so no marks are transferred onto the finished surface. Filler trim pieces are aligned with the correct clips and direction, because old plastic can crack easily when forced off center. She listens and feels for each locking clip, rather than using force to find a part that is not. The center console and seats are installed in a logical order, leaving enough space to reach wiring and floor bolts. Every seat mounting point is tightened to specification because it protects the occupants during sudden braking. The doors are rehung and aligned to the body gaps before the latches receive their final adjustment. She checks every door through several opening angles, ensuring hinges do not bind and new paint cannot rub. Inside each door, window and lock mechanisms are lubricated, while all drainage holes remain completely open. A moisture barrier is resealed after testing is complete, keeping rainwater away from the trim panel and electrical system. Door panels are fitted only after every mechanism works correctly, and weak clips are replaced instead of forced back into service. She operates the handles, locks, and windows repeatedly, confirming that no cable or wire is trapped behind the panel. The light-colored interior returns to its proper place, recreating the feeling of a car that left the factory years ago. Even then, she checks the seat belts and anchor points because a clean appearance can never replace safety. The windshield is lowered onto fresh adhesive using alignment marks, keeping an even gap around the frame without creating stress. She presses gently around the entire perimeter and secures it, giving the adhesive enough time to bond before the car moves. Once the glass adhesive cures, the perimeter is tested for leaks, and every small gap is sealed before the outer trim returns. A properly bonded windshield does more than stop rain. It also contributes to body rigidity while the car is moving. The trunk latch mechanism is readjusted after painting, so the lid closes easily while compressing the seal evenly. She lubricates the latch and taps it repeatedly by hand, preventing a jam after the car has returned to the road. Tail lamps and exterior details return to the wide body, with new seals keeping water out of the trunk. She powers and checks every exterior lamp, because one loose ground can make several bulbs behave incorrectly. Suspension bolts are checked again with a torque wrench, especially at points exposed to heavy loads and vibration. She marks each fastener after final tightening, providing a quick visual record of every completed inspection. The exhaust and muffler are suspended on new rubber hangers, with even clearance maintained beneath the body. She confirms that the exhaust touches nothing at any position, preventing vibration noise as engine speed increases. The rear brakes are completed with clean working surfaces, and the parking brake travel is correctly adjusted. After bleeding, the pedal must feel firm and hold steady pressure, and the car will not leave the shop if it continues to sink. All four wheels are installed and tightened in a cross pattern, seating each rim evenly against its hub. Tire pressures are balanced before the car is lowered, because unequal pressure could distort the road test results. With the car resting on its wheels, she inspects underneath once more, searching for oil, coolant, or fuel leaks after the waiting period. No drop of fluid is accepted as normal, because a small leak today can become major damage tomorrow. The interior is complete and every feature is tested again, from seats and belts to gauges and switches. She takes the driver's seat to feel the pedals and gear lever before moving the car out of the workshop. The sedan begins rolling under the power of its restored engine, while she listens to every sound during a slow acceleration. She tests the brakes, steering, and transmission step by step, never rushing until temperature and pressure remain stable. Thank you to all the friends of She Can Fix It. See you again on the next journey to bring a car back to life.